Hello everyone, welcome to my channel. In this video, we will configure a Profinet network between two S7 PLCs, either S7 1200 and S7 1500 PLC. There are many ways to communicate between two PLCs. In Siemens TIA portal, it allows user to establish the communication between S7 PLCs without programming both parties. Here we will use the get and put instruction in the master PLCs to read and write the data directly to the slave PLCs. In this case, slave PLC does not require any additional programming instructions. Let's start the Siemens TIA portal. Once the TIA portal open with existing project, select new project and project name it as S7 1200 PLC to PLC. Once you given created, it will open a new page, or you can give directly to the project view. In this project view, you have the first step. Here you can either configure a device or open a project view. In our case, I will open a project view directly. Once the project view opened, you can find in the left side menu called add new device. Double click the add new device, and in the controller sections you can find S7 1200 or 1500. You can select any one of them, and some of the CPUs is the old CPUs firmware. It will not support get and put options, so you need to select particular PLCs with higher firmware versions. So in our case, I am going to select CPU 1214C, and I will select this firmware 4.4, this CPU, and click OK. Okay, once it's created a new project with the new CPU, you can find in the left side PLC1 CPU 1214C AC DC relay. I will just copy one more for the same PLC. Just copy and paste in the same place, or you can go to the upper menu and enter paste. It will automatically copy the same CPU. Otherwise, you can select again from the add new device and add one more device, because we need one master PLC and one slave PLCs. So now we created two PLCs, PLC1 and PLC2. So now in our case, I will rename this PLC1 as master and PLC2 as slave. So right click the PLC1 and rename it master underscore PLC. Once you created the master underscore PLC1, and similarly you can rename the PLC2 as slave PLC. Once we created the master and slave PLC, go to the network view. Here you can find master and slave PLC. Drag and drop the Ethernet Profinet switch. See here, it will Profinet 4. It will configure directly if you drag and drop. Otherwise, you need to go one by one PLC. You need to change PN1 in the Profinet network address. In my case, I directly drag and drop. After you drag and drop, you can find in the downside of any one of the PLC, select the master PLC at first. From the downside, you can find, see here, you can find the Profinet interface first, and in the Ethernet section, you can find this IP address. See here, for the first one is now 192.168.0.1 and second one is 192.168.0.2. Select the same subnet, so it will match between these two. And if you go in the downside protection and security, you have connection mechanism. Click the add this permit access with put and get communication with remote partner. Once you select both the PLC1 and PLC2, save the application. So you configure the first part, like example, you interconnected between the two PLC and you configure the Profinet, and you make the tick mark for put and get option. So after you complete this section, Now we are going to make a programming section. For that, go to the program block for the master. Double click the main OB1. In this network one, you can select the communication part. Now see here in the right side option you have communication, and you can find S7 communication. You have get and put option. See, for the get option, drag and drop to the network one. Once you select the instruction for the get instruction in the network one, it will take little bit time, and you can just give open call option get db1. So it will automatically add the instruction in your network one. In this here you have one option called start configuration. See, for this or you can go to the properties, you can configure the same one. I will configure the start configuration. You just go first to the connection properties. In the right side of the partner, you have to give where you need to connect. Initially the master PLC you have in the master PLC, na? So you need to connect this one to the slave PLC. Once you add this configuration, it will automatically configure both PLC local and partner PLC. It will connect directly to the, so it will connect directly to between these two network. Once it's added both between these two local and partner PLCs, so you can see here the tick mark is green, and you can go to the block parameter. The block parameter you can find upside in the instruction itself. The same, it will be a request ID, see address, see request. Here it will request the setup communication given to the ID. So this initially it will be false. Either you can give true or false. This is boolean, and if you go for the ID, it will be there automatically as default. And now we will go for input and output section. Here the read area, it will be the address one. In this place you need to specify the area of the partner CPU that where it need to be read. And if you go for store area or D1, here you need to be give your local CPU address, start address, where it need to be take the data and send to the partner area. Therefore we have first read area, then store area, and it will be mentioned the description in everywhere, and also you need to give the length, and also you can give the parameters. These are the three sections we have to fill. And if you go further down, you can find indicator, error and status. See, in this place you can find also the same description for each one. So for us, first I will give the request. See here, you just go to the get db, it will and give the request directly, because once you add this instruction, it will automatically create the blocks, like the variables, it will create automatically, so you can give directly. So now in the NDR, just I need to go to the browse, and you can get you can see the get db, and you can directly enter .ndr, and if for the error also I will give you the same place, get db .error, and for the status just enter the same manner, get db, and you can find the status. So you can enter all this as automatically, and you can find easily. For the address and ID one, you cannot find directly, so you need to be configure this both, because you need to find where you need to read and where you need to send the data. So I need to create a new data block. For that, just I will go to new data block, and meantime you can create even directly as a default also. If you give some, like example, memory address or physical address, it will add directly and it will create in your data block directly. But in for better as a professional use, you need to be add this one as first data block. I will add a data block called read data block, and this one will send the data to the slave device. So I will give you slave data, and I will add one, and like OK for the global data. Once you add this one, it will be automatically create the db2. See here, slave data db2. So in the slave data name, I will give you signal1, signal underscore 1, and I will add signal underscore 2 and 3. And data types, it is default boolean. You can use any one of the data types here. I will select here as integer for testing purpose. And if you have any digital inputs, you can use boolean. If you have any parameters, you can use integer or real value. So you can give now signal number 3. I will use integer. So I created now 3 parameter, and it will be, you can keep everything as default. So once you created this signal, similarly you can create this one in the slave device also, because you need to send from master to slave device, no? So you need to add here also in the PLC tag of the slave device. Go to the program blocks, add a new block. In this place you can add for the receiving data, no? So I will add here for the new data block. It will take little bit time. See, in the data block I will give here master data, because it is coming from master PLC. So I will give the name called master data for our understanding purpose. And in the master data I will add the signal name, signal underscore 1. Before that I will give just for it is coming from master, so I will give master signal underscore 1 for our understanding purpose. And data type, I will use the same data type, integer, because if you give different data types, it will not read from one device to another device. So you have to use the same data type better. So I will give you master signal underscore true and master signal number 3 and under signal underscore 3. So I will add 3 data type. Okay. So now once you create this data block, then go to the main OB1 in the master PLC, and now in this address and read data, you just configure this both in this place. See here in the read data, you need to specify the partner CPU. Okay. So you need to give your partner CPU which we created now, this start address. So here you can give the data block address directly. If you know how to make the data block in the Siemens S7 PLC, you can give directly. See here the master DB1, it will mention DB1. No? So I will give you here DB1 dot DBX 0.0. This is the default address in the Siemens PLC. So I will give here the address DB1 dot DBX. See here you have to give the same X 0.0. So once you enter that address, you can find here, if it is red mark in the block, this means there is some error. If it is no red, this means it is okay. So see this address, it will be directly created here. No? This in the slave DB, this is for slave device, and this one it will be store device which we given here, and this is the master data which it's received from the master data, no? From this master PLC to the slave device. So that address, it will become like DBX 0.0, 0.1, 0.2 like that. So you need to understand that one. And the start value, it will come 048, because this one will be take integer, not it will take 2 registers or 4 registers based on your configuration. See here it will be automatically taken percentage db dot dbx 0.0, and the length is 3 because I am reading the 3 parameter. So I has to give 3 in the length. So how many parameters you are going to read, you need to enter the how many you configured, you need to give the same. And if you see the type, I given here integer type. So I configure the read, and for the store device you need to enter for the stored one, for the where it need to be stored. it should be specify the area on your local CPU. This means the master PLC DB data. So this is DB2 now for master PLC. So I need to give db2.dbx0.0, and the length also you have to give the same parameter 3, which is here. If you open here, you can find you already added 3 signals. So I have to give the 3 parameters you need to store. So I have to give here 3, because this one read from the slave device and it will store in your master PLC. Okay, therefore it mentions store area, and the length you have to give 3 and the parameter you have to give integer. See, you already configure all the parameter now, but if you see, still there is some error. It is showing red color. See, this means you need to see what is the error type, and if you go to that particular place, you can find the error. See, if you go here, see, you can find the error. Absolute access to the blocks with optimized access in is not permitted. This means in your DB you have some access, optimized access, it's already added, so you need to remove that access. So you need to untick that optimized access property. So for that we need to right click the DBs like DB2 and DB1, and you need to change that parameter. Now you will go there, see, in the parameter blocks, go to that master. See, you can, if you see in the properties, you already configure this permit access, so this is not an issue for us. So we need to close this master PLC parameter. So you cannot find here this error, so you need to check other parameter is okay, Profinet details and everything. So I will cancel this and go to the data db2, because it's come error in the db2.dbx0.0 na? So you need to check that parameter properties. See, when I check here, it looks everything is okay for me. So this error, it will be directly from the slave device. So I need to come here in the slave device. Now you can just go to the program blocks. The downside, you have slave data db2. Right click that one, go to the properties, and if you can find here, see here, optimized block access in the attributes, it's already have tick mark. So you have to remove this. You need to be untick this optimized block access. So this is our error. So you need to remove this one and give OK. Better I will remove this data block for OBC UA also, and I will save now. See, after you save also, we will see the same error. So for that you need to first compile and check, rebuild this software application. See, in the compile place, it is compiling now, and you did not find any error. So there is no error or warning in the application. This means everything looks okay, but it's still showing the error. So you need to change again this parameter. For that I will just go to this property again, the start configuration, or right click the property of this block. I will see, once I go there, it's gone already, because this one just, otherwise you need to retype this same db2.dbx, and also I will remove this db from this attribute again for this slave device as well. The attribute, just I will remove this optimized block access, and I will give OK. So I added this get db. Now it is ready to configure, like ready to read the data from the slave device. but I need to be send this data like not continuously, maybe whenever it is like it will read, it will give the status, and if there is any error it will be reset directly, no? Because if it is any error, sometimes it will hang the, like you cannot read again the PLC data. So you need to not get this, it should be read continuously from the PLC. So for that I will make one block here. So for that I will first add one network, and you can add directly from this insert network, or if you don't know, you just go here in this place basic instruction, and you can find the bit logic operation for set and reset block like the instruction. So I will take set and reset instruction, drag and drop to the network 2. If you know yes or this is set or reset, you can add directly from right click, add the instruction, and you can add directly also. So now I will add one normally close contact for the set, and here I will add for the get db dot request. So whenever it will request, whenever it is not request, it will set, and I will add this one to the slave get db itself for request for this set. And for the reset, I will add for any of the error or any of the DR, it will be automatically changed to reset this block. So for the reset, I will add for get db dot ndr, and for the normally this is whenever its ndr is appear, it will reset this block directly. And also I will add whenever there is any error appear, it will be automatically reset this block. Whenever the request is not there, it will set whenever and automatically reset from this. If there is any error, it will reset automatically. So this is the main function. It will be automatically take the communication in each cycle, and it will take all the data from the slave device. And now we completed for the get instruction. Now I will go to the put instruction. For that I need to write the data for the slave device. The read device, it is get. Now we need to make for write device. So I am using this put as for writing the database. For that I just added this put block, and similarly I will add here all the put instruction here, like put db underscore dot request, and also I will add for the same for the remote CPU. I just configure this connection, go to the connection, and you will select the partner CPU, similarly which we configured before. Similarly same things, slave PLC, and it will directly see, it will be give all the properties for the both, and it will be give it is no error. And if you go to the block properties parameters, and you have here input output write area. See here, if you see here, you can find, you can configure first here also directly. See here, done, put db dot done, put db dot error, and we can add put db dot status directly, because this will be automatically when you add this put instruction or any put or get instruction, this db will create directly. See, now when you see here in the properties, it will be added automatically in this request completion error and error status. So this all added automatically. So see, even you can add from directly from this place itself. So there is two way, either you can add directly from the block itself, or in the properties you can modify that one. So this one we completed. Now we need to add for address and store data, where you need to read the write the data, and where it need to be store the data. This is the two functions you need to be add, two parameters you need to add in your block. So for that, just we need to create again two data here. like example, one is for direct address like output data, and one is for store data. So again, if you go see here, you can find here right area, specify the area of partner CPU to be returned to, the start address, length, and the parameter you need to define here. Either you can give directly from the same place, it will be add your parameter address. Otherwise you have to create first in your you can add a new data block, or you can add in your data types here. So you can see in this place, just I will add in the slave data itself. I will right click I will add in the slave data type for write also. See here, just I will give here write data, master write data, and I will give master write to, and I will add two parameter now. See, now I will give here the address where I need to write the data for your partner CPU, db2.dbx 0.4, and I given the length 2 and integer. If you go here, specify the area on your local CPU from the which data to be returned should be sent. So here I need to specify the CPU to write the data. So I need to add in the slave device as well. See here you can add better, you need to be write this one in the separate data block. So what I will do now, see, when I added in the same data block, it is giving me some error. So I will add a new data block and named as write underscore data. Once I given OK, it will be add new data block here, db2 write data db2, and I will add the same address here for write from master to slave device. So I will give the database here write underscore 1, and I will give the data type called integer. And for your case, you can give anything for the data types, integer, boolean, real, or anything, no issue for that. Once you create this write data, see here, I will change now to the properties. See, I given the, now for this send data, I need to use db2. You see here, the write data is db2. Na? So I need to change this one to db2. db1.dbx 0.0. Sorry, just I need to change this one to db2, and the length should be 2 and the parameter is integer. You see, this is the db2, so I need to give this one db2. Once I given db2, you get, see, the error is there is no error, and the network is okay now. So it is ready to configure the two PLCs. So once you completed this one, download this application to your PLC and it will work. This is now you can configure this similar way for the S7 1500 PLC as well. See, I configured here CPU 1515, and I added the same get and put parameter here as well. And see here, I can give direct address directly from this place itself. See, in this place, if you enter some value for the read or write, it will be directly taken, it will create a tag directly. See here, I give m0.0, it is added tag 3 directly. See, and also I given the length 1 for testing purpose, and I will give here, see, any of the character like example word. See, it's created directly, so there is no any error. You can add here m0.2, m0.3. This is like memory address, you can add as well, and also you can add your physical address of the PLC. See, this is your partner PLC address, so it will create directly to these places itself. Internally it will create these tag names, so you don't need to worry about these tags. If you add directly from this read and write device address, it will be add read area, and it will store in the stored area as well. See, M20.2, it will be added directly. So don't need to be worry about this more. If you know the exact address, you can give directly from that place, or you can directly enter in this place itself, in this read area and store area, and give the length of your parameter, and give the exactly like what type of parameter, like boolean or word or integer, real, or anything. Even you can do the combination between any PLCs from S7 series, S7 1200 to 1500 or 1500 to 1200, or any combination. It will work perfectly for these communications. Soon I will make some other videos, different communication method between these two PLCs, and I will share in the next videos. Thank you for watching this video. If you have any comments, kindly put in the comment section, and if you like this video, kindly press the like button and share to your friends. Thank you.